Hello students, welcome back. In this video, we are going to add a pressure system to our game, something that is going to force the player to make timely decisions, use their resources, and potentially put them in harm's way. And this pressure system is going to come in the form of asteroids. So we already have our ramp system built to control how fast our asteroids are moving and how many asteroids we create every time we spawn asteroids. Now we just need to create the asteroid objects. So by the end of this video, asteroids will be moving across the screen in random directions, creating sort of a sense of an obstacle that our probe has to maneuver through. So let's head over to our computer screen and we'll dive right in. So I have lesson 6's starter file open here in vscode.dev. I'm also going to minimize my browser and open that file directly. So we're going to click right here on your AstroDrift folder, which is on your desktop, and open lesson 6's starter file. So let's see what we look like here when we start the game. So here we have it. All right. So motion works, fuel system is working, drifting and drag seems to be working fine. Our time system is great. Our ramp is active, but I see no asteroids spawning, so that's not good. So our asteroid system is not yet fully operational. No surprise there. That's the scope of this lesson. That's what we're going to work on. So let's go to mission number 1 here in our mission checklist. Anytime we add a new system to our game, we're going to try to start by adding constants for that system. These are the things that we can tweak and adjust to change how that system plays, feels, or looks within our game. So our asteroid system is no different, and these things are going to be found in your student edit zone. So if we scroll right down to our student edit zone, we should see mission number 1. Here it is, our asteroid constants. So let's look at what we have here in terms of variables for our asteroid system. So I have asteroid spawn interval in seconds. So how long do we want to go before we spawn an asteroid? And this is going to be a constant throughout our game. What's going to change is when we spawn the asteroids, how many asteroids do we create? So I think early on, we're only going to create one asteroid. Yep, one asteroid. And then when it's time to spawn, we'll create another one and another one. But if our ramp says, hey, it's time to increase the spawn to 2 asteroids, the next time we'll spawn 2, and then 3, and then we'll get to 4. So right now it says we're going to spawn our asteroid bundle every 100 seconds. That seems ridiculously high. Let's change it. I'm gonna spawn an asteroid every 1.5 seconds, or a collection of asteroids every 1.5 seconds. Our asteroids are going to have different sizes. So we're going to use circles here. So we're going to specify the size in terms of radius. We have the minimum radius and a maximum radius. And what we'll do is we'll randomly select from those values so that we get varying sizes of our asteroids. So my minimum radius is going to be 15 and my maximum radius will be 35. Oh, 35. There we go. And then let's see, we have asteroid vertical speed min and asteroid vertical speed max. Okay, so we know, if I come back over here, our ramp is controlling the asteroid's speed. So this is the speed that they're moving across the screen, right? So they're moving slowly across the screen, then faster, and then faster across the screen. But we also want to have vertical speed. And the vertical speed I'm going to make random, so it might seem like some asteroids are drifting off in this direction, some asteroids are drifting off in this direction, some asteroids are drifting off in that direction. And we will control that. We won't vary that with our ramp. Our ramp is only going to vary how quickly the asteroids are moving towards us horizontally. So in here, let's set our minimum and max speeds to be, I'll do negative 35 to 35. So we'll have a range there of like 70 in terms of our difference in vertical speed. And then I have something called asteroid off-screen buffer. So when we create our asteroids, when we spawn asteroids, we're going to spawn them over here, and they're going to be moving to the left. That's our goal. But if we create them right here on the screen, these asteroids are just going to appear into our world. I don't necessarily want that. So what I'm going to do is I'm going to spawn them someplace over here, and they will move and then they will begin to appear as if they're entering our game world. So we're going to spawn them off the screen. And the distance off the screen that I'm going to spawn them is given here by this asteroid off-screen buffer constant. So I'm going to set that to 60. That'll be the value that I chose here. All right, our constants are set, but these are just the constants, the things we can tune for our asteroid system. Let's also scroll down and see what else we have here for our asteroid system. Like in our color palette, okay, I have asteroid body color, so my asteroid's body, and then it looks like we're gonna have craters on our asteroids too. So I've got a body color and a crater color. And let's see if we get any new gameplay variables. So for our gameplay variables, okay, it looks like we have an array or a container for our asteroids, and then a variable called asteroid spawn timer seconds, and it's set equal to 0. Now we've seen an array before briefly. We talked about it when we mentioned building our stars for our background, but really we didn't go too in depth in it. So I want to talk a little bit about an array. So an array is defined as these square brackets, and you can think of it as a container that you can put objects in. So right now our asteroid container is empty because there's no asteroids created. But imagine if I spawned a couple of asteroids. I can put them in this container. So I'll say asteroid 1, asteroid 2, asteroid 3, asteroid 4. So right now, this container is holding 4 asteroids. And I maybe think like I want to do some operations to all of these. So maybe I want to like move them across the screen. Well, I'd have to write code to move this asteroid, and this asteroid, and this asteroid, and this asteroid. Well, that's a lot. So what I can do is I can write code that targets this container or this array and write the code once and apply it to everything that is inside of the array. And that's the beauty of arrays. They're a way for us to collect and organize data and then do mass manipulations to that data. Now, an interesting thing about this array, these objects, my asteroids here, asteroids 1, 2, 3, and 4, they can be found at any position in the array, and we start those positions at 0. So this first asteroid is at position or index 0. Our next one is at index 1, our next one is at index 2, and our next one is at index 3. And we can move through the array using something called a for loop. So we're going to see this a lot here in this video as we work with arrays, working with this type of this idea of using a for loop to move through our array. So that's going to be where we put our asteroids. And then what is asteroid spawn timer seconds? Well, we're going to say, okay, we're going to have a timer or a countdown, and we'll maybe start it at, let's see, maybe we started at 1.5 seconds, right? And then every frame, we're going to use our delta time variable to decrease that spawn timer. And once it hits 0, then we know it's time to create some asteroids. And so that'll be that gives us our ability to know when it's time to actually create our asteroids. All right, so let's move now into mission number 2. We have a good idea, hopefully, of what we have here for the asteroid system. Mission 2 is all about setting up our asteroid data. So it says, we're in a function called generate asteroid data. It says complete the asteroid data object, include position, size, and movement values. Okay, so we're creating and spawning new objects into our game world, right? Our asteroids, we're going to constantly be creating these objects. And when we find ourselves in that situation where we're going to be putting new objects into our game world, I typically use 3 functions. So we'll have a function that generates data for the object. And so that's this function. Then we'll have a function that spawns our object, so spawn asteroids. And then we'll have a function that updates our objects, so update asteroids. Anytime we got to put an object or a collection of objects into our world, we'll generate the data, we'll spawn the data, and we will update the data. That's the system that I typically use. So let's go look at this generate asteroid data function. So what's it doing? Well, right off the bat, it looks like we define a constant variable called radius. So that's something that's not going to change throughout this function. And we're randomly selecting from our minimum asteroid radius, which we set to be 15, and our maximum asteroid radius, which is 35. So every time we generate an asteroid, it's going to get a random size. All right, but that is just a variable. It's not like attached to the asteroid yet. And so if you look here, we are returning, this function returns or gives back an object. This object inside our curly brackets has 5 properties. The 5 properties are an x property, a y property, a radius, a Vx or horizontal velocity, and a Vy or a vertical velocity. So we want to make sure that these are all set correctly, because I think some of them are not. If we look, our x property, so where are we going to, when we create an asteroid, where do we want to position its horizontal property? Well, it's saying width, which is the width of our canvas. All right, so all the way over here. And then what are we doing? We're adding our asteroid off-screen buffer, which we set to be 60. So it's going to take it, and now it's going to put it over here. And then we're adding, again, what does it say? A random value between 0 and 120. And that's good because we don't want to spawn everything right over here, because if we spawn everything at the same horizontal position, when they move, they're going to move just like a row or an entire column. So we're going to spawn one here, one here, one here, one here, and then when they move, it will look random, like it's a field of asteroids coming towards us. So I think our X position looks great. How about our Y position? Well, we're randomly selecting from the HUD height. So HUD height, we're starting here, plus the asteroid's radius. So we're going to make sure that we're down a little bit so they're not going to spawn because the asteroid is going to be defined by the center of its circle. So we're going to make sure we move down by the radius. So they're going to be spawning completely in our battlefield. And we're going to go all the way down to the height of our canvas, which is going to put our asteroid center right here at the bottom. But half of the asteroid could be off the screen, so we move it back up the radius. So I think our Y values look great. But our radius does not look great. The radius property of the asteroid that we just created is set to 0. Ooh, that's no good. That would be a super small asteroid. So what I'm going to do is I'm going to set it equal to the radius variable that we defined right up here. So we got to change that. Radius. Awesome. All right, right now its horizontal velocity is set to 0. Well, that would be really bad. We don't want that to happen. I guess we want the asteroids to move to the left, right? So they're going to start over here and we want them to drift to the left. So that's going to be negative. We're going to give it a negative horizontal velocity. So what size should we use? I mean, I guess I could just do like negative 20, a 120. I could do negative 120. I could do negative 50. But really, I want these asteroids to speed up. Right? They're going to speed up as the game goes on and on. That's what's going to make the game difficult. So what controls that speed? Oh, it's our ramp. So if I go to update ramp value, I have a variable called asteroid speed that is going to constantly be changed. It's going to start at 50 and it's going to end at 320 based off the value of the ramp that we defined. So let's use that asteroid speed here to control the speed of the asteroid in the x direction when we generate it. So let's use that variable, asteroid negative. We're going to negate it so it goes to the left. Asteroid speed, and I'll hit tab for autocomplete. And then I need my vertical direction. Oh, I have a semicolon there. That should be a comma. There we go. And then I need my vertical direction. So in the vertical direction, we wanted to, I think, randomly move it in the y direction. So I'm going to use random. I'll spell it right. And then I think we set constants for our asteroids vertical. See it all the way down here. So this is going to be vertical max, and this is going to be vertical min because they're in alphabetical. So I'll click the second one for asteroid vertical min, and then I'll do the first one here for asteroid vertical max. Hey, I think our data object is done. So we've generated that data. Right here is all the information that we need to create an asteroid. So that represents a given asteroid. Of course, if I run our program right now, no asteroids are created because the data object is in place. But the question is, are we actually creating any of these data objects? I don't think we are yet. So we built the data structure, but we're not creating the data structure. And I think that's where mission 3 is going to lead us. So let's head over to mission number 3. And mission number 3 puts us exactly below the generate asteroid data function that we were just working in and puts us in our spawn asteroids function. All right, so what are we doing? Well, it says for, so we're going to use a for loop. And that for loop means we are going to repeat a section of code over and over and over again. How many times are we going to repeat it? Well, let's see, we have a number that's going to determine this. It says let I equal 0. and then I less than asteroids per spawn, I plus plus. So we're going to repeat this over and over and over again based on these conditions. So let's just take a look here. So I is going to start at 0, and it's going to go, so let's see, I starts at 0 and goes till I is less than, so asteroids per spawn. If we remember, asteroids per spawn is something that is, again, controlled by our ramp. Let's go take a look at our ramp. So here's asteroids per spawn. We start at 1, and at the end of our game, we will be at 4. So let's assume that we are at, we'll say 3. So we'll say I starts at 0 and goes until I is less than 3. Let's just say we have 3 asteroids per spawn. So I will be 0 on the first time this code executes, and then I plus plus says increase i's value by 1. So on the next time we run this loop, I would be 1. Then the next time, I would be 2. And the next time, when I is 3, 3 is not less than 3. So this condition right here would be false, and the loop would stop. So in this case, I would have a value of 0, then 1, then 2, and we would stop the loop. It would run 3 times, creating 3 asteroids. That's our goal here. We want to create 3 asteroids. So how am I going to create 3 asteroids? I need one line of code that I'm going to repeat over and over and over again. Well, we're going to use this generate asteroid data function that we just wrote, because it returns to us when we call it. It gives back to us that asteroid object. So remember, we had an array or a container that we could put all of our asteroids in. So I'm going to do asteroids dot. Okay, so there's the container, and when you want to put something into your container, you are going to call dot push. And what push is going to do is it's going to take your container and it's going to push something into it right at the end of it. What is it going to push in? Well, we want it to push in an asteroid, but we have to create or generate the data for our asteroids first. Thankfully, we have a function that does that for us. And when we call this function, it's going to return or give back to us this object that we are creating. So right here, if we want to push an asteroid into our container or array, asteroids, I'm going to call inside of this push method, generate asteroid data. Now, you got to make sure you have parentheses here in order to call that. So right here, I'm calling that function. That function will run. It builds this object for an asteroid and returns it. So this whole object takes the place of this function call. And it's that object that we're pushing or storing into our array asteroids. Awesome. So right now, I think that looks like it should be pretty good. So let's just see if this is working. Let's see. All right. Any asteroids coming? Any asteroids coming? I don't know if any asteroids are coming. I think it's probably because we actually have to call this function. Are we calling this function anywhere? I don't know if we are. Let's just go up to in reset games to default. Let's test this by in reset games to default. We're going to put a debug line in our reset games to default function. Let's just do spawn asteroid and spawn asteroids. I'm going to spawn a few of them. Spawn asteroids. Let's manually spawn them. Let's see if they show up yet. So let's refresh the game. Because remember, these are going to be controlled by a timer, and we don't have a timer yet. Ooh, look at that. That's sort of an asteroid. I better move. Oh boy. Okay, I made it. I don't know if that's really an asteroid. I mean, those sort of look like asteroid craters. They're not fully there. So this looks like it's pretty good. So our asteroid system is working, but our spawning is not yet working because we're supposed to control these on a timer. That still needs to be implemented. So we'll leave these manual spawn calls in our reset game to defaults right now, and then we'll take them out at the end. But more alarming was our asteroids just looked like some craters. So mission number 4 brings us to our draw function for the asteroids because right now we're not drawing them correctly. We've defined the data. We are updating the data. We're moving it correctly, but we are not We're not drawing the data correctly. So let's look at draw asteroids. This function gets called inside of our draw scene. We draw a background, our asteroids, our player, our HUD, and our overlays if certain conditions are met. And so for draw asteroids, we say, hey, give me an invisible marker so you don't see the outline of the shape that I am about to draw. And then we have another for loop. This for loop looks a little different though. It says for const asteroid of asteroids. This time our array doesn't need to be filled. It's already got a bunch of stuff in it. It's got asteroid 1, asteroid 2, and asteroid 3 in our case. And so what we're going to do here is when we loop through this, it says, hey, take that array that has things in it, our asteroids, and loop over it. And so this is going to be our variable, asteroid. The first time our loop runs, asteroid is going to be this first asteroid, AST1. The second time, asteroid will be AST2. And the third time, it will be AST3. And then when it runs out of things in the array, the loop will stop. So this is a nice way to loop directly over a list or an array that has elements inside of it. Especially if all you want to do is just use the elements, this is the way. So for const asteroid of asteroids, we want to draw the asteroid's body. All right, make the hazards clearly visible. So it looks like we're drawing the craters. Here's the stuff for the craters. So that makes sense because they appear nicely. So now I think we got to put a new paint in our paint bucket because we have an asteroid's body color right here. So this third one down, asteroid body color. And now I'm going to draw a big circle for the asteroid's body. So the circle function. The circle function takes in the x and y coordinate of the circle's center. So those are stored in our asteroid object. Remember, we created that asteroid object that had an x property and a y property. So we're going to use its x property for the x coordinate of the center and asteroid.y for the y coordinate of the center. And then I need the diameter of the asteroid. Well, we have a property called radius, asteroid dot radius. And I'm going to multiply that by 2 because the diameter, or the distance from one end of the circle to the other, is twice the radius. And with that, we now should see our asteroids much better. So let me refresh the game, and let's see those 3 asteroids that we're spawning manually. Ooh, those look really, really good. Let's refresh the game again. So now they're in different positions, okay. It looks like their horizontal speed is working, but they have no vertical speed at all. They're just moving horizontally. So that is broken still. I think we got to fix that VX. We've given it to the asteroid. The asteroid's aware that it has a vertical velocity, but it's not being used properly. So we got to fix that. So let's head back to our code and look at mission number 5. All right, so I'm going to come back up here to my search bar, mission number 5. All right, mission number 5 says update asteroid movement using velocity and delta time. So if I come down here, this puts me in my update asteroids function. So we have access to our delta time variable here in update asteroids. And if we look, all right, so asteroid movement says update asteroids position and velocity with using velocity and delta time. Keep asteroid movement smooth and time-based. So if we look here at this line, it looks like we have, what, the X movement is working? Okay. Hey, look, we got another for loop. This is great. We have another for loop here. And this for loop looks slightly different than both of the for loops that we've looked at. So this for loop says, hey, for let I equal asteroids.length minus 1, I greater than equal to 0, I minus minus. So we got to talk about this for a second because we're going to need to know this coming up here in a second anyway. So let me align these. So here is just some like examples of what an array is, our container, and let's just pretend we have 4 asteroids in our array. So this array has a length, okay? The length is the number of elements in it. So right now our length is equal to 4. So if our length is equal to 4, we're defining I as 4 minus 1, which is 3. So I starts at 3. That gives us this last element in the array. Essentially, what we're doing is we're running our for loop from the end of the array. So this is the end of the array, the last position, because we start counting at 0 here. 0, 1, 2, 3 gives me a length of 4. And we're going to go until I is greater than or equal to 0, and we're going to subtract 1 from I each time. So it's going to go 3, then 2, then 1, then 0, and on the next iteration of our loop, if we subtracted 1, I would be -1. But -1 is not greater than or equal to 0, so the loop would stop. So we are essentially looping backwards through the array. And so we can actually pick out an element from our array using I. So if I just typed out the name of my array, asteroids, square brackets, and then I put in an index in here. So a position, if I said, hey, position 2, this means go in and grab the asteroid that is at position 2. And so we could work with asteroid 3. If I changed it to 0, I could go in and work with the asteroid at position 0. But we can put in our variable I, which now will go and grab this asteroid, do some operations, this asteroid, do some operations, this asteroid, do some operations, and this asteroid, and do some operations. We are looping backwards over the array. And this is what you want to do anytime there's a chance you want to remove something from the array. So if we're going to remove an element from the array, we're going to loop backwards over it. And it's just going to prevent some sticky situations we might find ourselves if we were looping forwards through the array. Now, why would we want to remove our asteroids? Well, look here. If our asteroids are drifting, there they go, there they go, there they go. They are sufficiently off the screen. We want to destroy them now because otherwise they're just going to continue to drift forever and ever and ever and take up resources in our game. We don't want that to happen. So we got to remove them, which is why we're looping backwards over our array. All right, so we've seen, 3 nice ways that we can use for loops. We can loop forwards through an array. We can loop directly over our elements, or we can loop backwards through an array. So right now, let's use that idea here to update the asteroid movement for all of the asteroids that are currently in our array. We have 3 of them. It looks like our x velocities are working nicely, but our y velocities are a little messed up. So if we look, we're going into our container, our array called asteroids, and we're selecting an asteroid at a specific position, the I position. So I'm going to do that again. I'm going to do asteroids. So open up our container and give me the asteroid that is at the I position. So we're going to start at the end. It would be asteroid at position 3, then at position 2, then at position 1, and then at position 0. And I'm going to target that particular asteroid's Y property. And I'm going to add to it that particular asteroid's vertical velocity, so Vy. But then we're going to take that velocity and we're going to multiply by dt because velocity times time tells us the distance that we need to move in that given direction. So now we've added that broken line. Let's come over here and let's see, do our asteroids now have some vertical velocity? Oh, my game is broken. I must have made a mistake. And I did make a mistake. Ooh, this is a good lesson. I wrote asteroid, square brackets I. Asteroid is not a container. It's not an array. My array is called asteroids. So we got to be really careful there. I made a mistake. We'll put asteroids, square brackets I. So open up my container, my array called asteroids, and select the correct asteroid. Now, if I refresh the game, can I hit enter? I can. Do my asteroids move in the vertical direction? Ooh, they do. This looks really good. Now it's like I really got to work to avoid. I'm going to thread the needle. Woo! That was actually pretty fun. Okay, so this looks great. This is working awesome. Of course, once we get past that first round of 3 asteroids, there are no more asteroids coming our way. That's super, 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 super sad. So what we've got to do is we got to use our spawn timer to correctly spawn more and more asteroids. Let's see what mission 6 has us doing. Mission 6 says, add the asteroid spawn timer logic. Perfect. So this is exactly where we got to find ourselves. So mission 6, we are in update asteroids. Okay, so if we look here, it says asteroid spawn timer in seconds. So we're subtracting dt from our asteroid spawn timer. And then we're checking if our spawn timer is less than or equal to 0. What do we want to do? Well, it says update the asteroid spawn timer and spawn the asteroids when the spawn timer reaches 0. So we're pretty darn close. I mean, we're updating the spawn timer, and when it's equal to 0, that just means it's time to make some asteroids. Spawn asteroids. So how are we going to spawn our asteroids? Oh, we have a function that does that for us, right? We have spawn asteroids. So let's just call that function. Let's just do spawn asteroids. We already wrote that. So we'll call spawn asteroids. Now let's just make sure, where is our timer actually being set? So I'm just going to go up to like my gameplay variables. Let's walk through this logic here. When we create our game, we created the timer and it was set to 0. All right, so it's 0 here, but if I go down to reset game to defaults, when we reset our game, right, I reposition the player, I draw my stars, I reset the fuel system, I reset the ramp. I also reset my asteroid system. I empty out my asteroid array, and then I set that spawn timer equal to our constant asteroid spawn timer interval seconds. So our game is going to start with a timer of 1.5 seconds for us. So we'll go through and we'll subtract off our DT, our time since each frame has elapsed, and once it hits 0, we're going to spawn our asteroids. So let's take a look at what happens here right now. So we should have our 3 asteroids right off the bat. Boom, ba-doom, there's our 3, and then, oh my God, run, quick. This is really comical. This is way too many asteroids. I think we're gonna die. Yeah, that's dead. What the heck is going on here? Oh, I know. It's because we set the spawn timer to 0, right? So our spawn timer has hit 0, which makes this true. We spawn an asteroid. The next frame, we subtract more time from 0. So now it's like in the negatives. It might be like negative 0.05 seconds. Well, that's less than 0. So on the next frame, we spawn an asteroid. And then we subtract again, and it's still negative, which is less than 0. So we spawn another asteroid. And we find ourselves spawning asteroids every single frame of our game, which is no good. That's why we had this crazy field of asteroids right here. So what we need to do is after we spawn an asteroid, we have to reset the timer. So I'm going to do asteroid spawn timer seconds, which is the thing that we were looking at, and I'm going to assign it back to our asteroid spawn interval seconds. So autocomplete there, tab is our friend. Now, once we create an asteroid, we set our timer back to 1.5 seconds. Now I should at least have a chance. Let's just see. All right, so there is our asteroid field. And I can sort of move through, zoom through. All right, I'm liking this. Oh, this is fun. This adds some element to our game that is quite nice. Oh, of course I can just fly right over an asteroid. So the asteroids right now are purely visual. So we got to add a little bit here still. So let's look at mission number 7. Ooh, mission number 7 is all about our off-screen cleanup. We said that when our asteroids get over here, right now, we're eventually going to want to remove them from our list, our array. Because right now, they're still there, and they just keep going and going and going, building up in our system resources. So mission 7 says, if, we ask a question right here, if the asteroid's X position plus the asteroid's radius is less than the negative asteroid off-screen buffer, which we said was 60. We set our asteroid off-screen buffer to 60, so when we spawn them, we're going to spawn them over here, and when we remove them, we're going to remove them over here. So this is 0, which means negative off-screen buffer is going to push us to the left. So once our asteroid's X position hits that spot over here, and we add the radius into it. I guess we probably don't have to. It's just for consistency. We want to say, all right, if this question is true, they are off the left side of the screen, it is time to remove our asteroids. So the way you remove an element from the array, first, we'll note that you always want to loop backwards through the array, which we're doing right here. And so now I'm going to target the array, asteroids, which holds all of my asteroids. It's my container. And instead of calling the push method, which puts something into the array, I'm going to call .splice. Splice will remove something from the array. We just have to specify what position we want to remove from the array. I want to remove the asteroid that is at position I, because that's the asteroid that is moved off the screen. And then we have to say, hey, starting at that position, how many asteroids do you want to remove? Well, I only want to remove 1 asteroid starting at that position. All right, so now if we run our game, it's going to look exactly the same. We're not going to see these asteroids over here getting removed, but we'll know that when they get there, the asteroids will be removed sufficiently. All right, and we could probably add one in the vertical direction, but like, Okay, one of these ones that are like going off the screen here, they'll eventually hit that over here, and then they'll get removed anyway. So our system resources are not going to get bogged down now as our asteroids are being destroyed. One last thing we severely need, though, is we got to collide with these asteroids for game over. So let's take a look at mission number 8. It says asteroid collision. Detect asteroid collisions between the player and the asteroids. Trigger a loss when the ship is hit. All right, so in here, this function is called check player asteroid collisions. And if we look, is this getting called every frame? Every frame our draw function runs. If we're in the play mode, we are also calling check player asteroid collision. So this is perfect. We're going to run this every single frame and see if we're colliding with our asteroids. So how's this work? Well, we're looping over all of our asteroids. We're just looping directly. I'm not removing anything from the array, so I don't need to loop backwards. It says for const asteroid of asteroids. I get dx, dy, hit zone. I guess I want to figure out, is there a collision? So I've got this question right here that just says if false. Well, false is always going to answer to no. So we want to ask a question here, and the question should be, is there a collision between our asteroid and our player? And if the answer is yes, then we set our game mode to lose, and we get out of this function, we return. So that means like it's game over. So how do we figure out if there was a collision? Well, this is going to be a little bit of math. We're going to come over here really quickly to our whiteboard, and let's explain this. So imagine here is my player. Okay, so here's my player. Oh, I'll make this, we'll say here's my player, boop, player, and here is an asteroid, okay, an asteroid. And those things have centers with X and Y positions. So right now, you could say there is definitely no collision. How do we know there's no collision? Because look, there's some length away from each other. There's some length away. Now, how do we know what that length is? Well, we can actually determine how far away the player and the asteroid are if we look at the difference in their x positions, how far away they are in the x direction, so I'll call that dx, and how far away they are in the y direction, I'll call that dy. Now, how do we get dx and dy? Well, dx is just going to be the player's x position minus the asteroid's x position. And those are properties that each of those objects have. And, well, actually, let me write that. I'll change that. I'll do the asteroid's x position minus the player's x position. It doesn't necessarily matter. I'll do the asteroid's x position minus the player's x position. How are we going to get dy? Well, dy will take the asteroid's y position and subtract the player's y position. So we've got the way to find dx and dy. And I'm going to call dx, I'll refer to dx as side A of my triangle here. I'll refer to dy as side B of my triangle. And this length, the distance away from our player and our asteroid, has a special name. It's the longest side of our triangle. This is known as the hypotenuse, and we often refer to this as side C, because there's a really nice relationship for these three sides called the Pythagorean theorem, which says a squared plus b squared is equal to c squared. So if you take your a side, which is dx, and you square it, and you add to it your b side squared, so dy squared, that will equal your hypotenuse, which is our length squared. But I don't necessarily want to know my length, I guess. I don't want to know my length squared. I want to know my length. So we got to undo this squared. So we'll take the square root of both sides. And when you do that, those cancel. And so the length, or how far away we are from our asteroid, is given by the square root of dx squared plus dy squared. All right, so now we can figure out how far away we are from the asteroid. So at what point does this value indicate that it's a collision? Well, let's see. If we moved here, is it a collision? No. Length got smaller, but it's not a collision yet. What about here? Length got smaller, but it's not a collision yet. When does it happen? Well, let's just see. Like right here, yeah, because there's overlap, we have collided. So when does that overlap happen? Well, that overlap is going to happen when we have, let's see, here's our player. Here's our asteroid. Okay, the player has a radius. I'll call it R1. The asteroid has a radius. I'll call it R2. And this distance right here that these two radii together make, if we add them, the player's radius plus our asteroid's radius, I'll refer to that as our hit zone. because if our length or distance away gets smaller than that hit zone, we know there's overlap. So let's take a look. We could say, okay, if our length is less than or equal to our hit zone, that is a hit. That means we have a collision. But there's only one, so I can substitute in for length because I know how to solve for the length. It's the square root of dx squared plus dy squared is less than or equal to our hit zone. And this works. This works wonderfully. But we don't typically like to take a square root if we don't have to take a square root. And I don't have to take a square root. I can undo this square root right here by squaring both sides. So if I square this side and I square this side, the square roots will cancel, all right? And I can say, all right, dx squared plus dy squared less than or equal to hit zone squared. That is our condition that if this is true, then this means we have a collision between our player and our asteroid. So let's put this math into practice in our code. Let's take a look at it. So we'll come back over here. It looks like we calculate our dx variables by taking the asteroid's x position, subtracting the player's x position. We calculate our dy variable by our asteroid's y position, subtracting our player's y position. And we calculate our hit zone by adding the two radii of our asteroid and our player. So now we want to ask our questions. We've got our variables here. So using that Pythagorean theorem, we're going to say if dx squared plus dy squared is less than or equal to our hit zone squared, then our asteroids are about to overlap, and it should be game over here. All right, our collision method is done. Let's run this. Let's see if our asteroid system is now fully operational. We'll press enter to launch. We'll spawn 3 right at the beginning. Here they go. And then our timer is giving us some more asteroids. So I'm just going to run right into one. Let's just see. So I can move around. I got to actually practice. All right. And as soon as we collided, it was game over. Let's see one more time. I'm going to spam right into one. Perfect. So our asteroid system is set here. This is really great. We now have that pressure system. We actually have real gameplay. Before, we were just a little probe wandering through space, aimlessly with no goal in mind. But now we have a goal. Our goal is to survive. This system adds that gameplay element that I think we were missing. And it now takes something that was playable and makes it playable and fun. So this is a great place to stop. And I'll see you in our next video.